Okay, proposition 4. If two triangles have two sides equal to two sides respectively and have the angles enclosed by the equal straight lines equal, then they will also have the base equal to the base and the triangle will be equal to the triangle, and the remaining angles subtended by the equal sides will be equal to the corresponding remaining angles. Okay, so let's draw these triangles. So let's say, right, it doesn't matter what the lengths of the sides are, but now the thing is we want to have the same triangle. Okay, so you have these two triangles. Now what the proposition says is you have two triangles ABC and DEF. If you have two sides equal to two sides, so you have this equal to this and this is equal to this. It is given. So what is given? Given is AB is equal to DE. AC is equal to DF. And the angle enclosed between them, that is this angle and this angle, they are equal. So angle BAC is equal to angle EDF. This is given. Then what the proposition says is that the rest of the triangles angles and sides will be equal. That means the third side will be equal to the third side of this. This angle will be equal to this angle. This angle will be equal to this angle. So now how do we prove it? Now if we take this triangle and put it on top of this, right, by keeping the vertex A on top of D, what will happen? We are taking this triangle and keeping it on this triangle, so where A corresponds to D. So A is on top of D. Naturally, if we have rotated a little bit, we have to make sure that it aligns with this triangle. So what you will notice is that AB will correspond to D. Similarly, AC will correspond to DF, because that is what is given to us. Now, because of this angle, E and F and B and C, BC will match, right? B will be on top of E because of AB equal to DE. Similarly, AC will match DF. And once you take care of the angle, then BC will map to EF. Now the point is that we have to show that they are equal. Now imagine a situation where they are not equal. Now if they are not equal, what would it mean? What it would mean is that even though we have kept ABC on top of triangle DEF, EF doesn't match BC, which means that, let's say, right, E corresponds to, B, C corresponds to F, but the line itself doesn't match. That means you have two separate lines connecting BC and EF. So although the points match, but the lines connecting them do not match. So which means that you have an area between these two lines, and even otherwise also. Remember one of the axioms? What does it say? It says you can have only a single unique line between 2 points, right? So you can have only one unique line. One and unique both mean the same thing. Only one line or only a unique line can be drawn between 2 points. So here what we are arriving at is that there are two lines which goes against the axiom. So which means that BC also matches. So therefore AB equal to DE. This should be AC. AC is equal to DF. BC is equal to EF. Implies. Similarly, angle BAC equal to angle EDF. The whole thing basically implies, as far as angles are concerned, that ABC angle is equal to angle DEF. Angle BFE is equal to angle ACB. So that's why we say, see, in the proposition Euclid says the triangle will be equal to the other triangle. Here now we say, we don't talk of being equal, we say triangle ABC is congruent to triangle DEF. So this is nothing but your side angle side. So that is proposition 4.